Alright, so I believe I'm recording. Let's take a look at problem number 4. On these graphs of functions, we're to identify intervals on which the function is increasing, decreasing, or constant. It appears here that we have a quadratic function. The graph looks to be like a parabola, and it's opening downward. As we enter the graph, we always enter from the left and move from left to right. On the left, the arrow tells us two pieces of information. We break it down, and we say those two pieces of information are telling us that since this graph, as you move to the left, you're moving down, that the x-coordinates, as that goes to negative infinity, the y-coordinates are also going to negative infinity, and over here on the other side, on the right side of the graph, that arrow is telling us as x goes to positive infinity, the y values are going to negative infinity. We can relate the increasing, decreasing, or constant to our notion of slope that we learned in Algebra 1. We know that as you enter the graph here on this arrow, you're going up, you're going up, you're going up. There's no change, so we're still shading it the same color. We reach the vertex and there's a change. And then from then on to the right, as you're moving to the right, you're going down. So if you're in this yellow region and you pick any 2 points that have x-coordinates that are less than 0, then as x increases, y is increasing. But if you pick any 2 points that are in the green region, as x increases, y is decreasing. So over here, the output of this function, the y-coordinates, are getting bigger, they're increasing, and over here, as you move to the right, the y values are decreasing. So we need to describe these intervals using interval notation. We use x-coordinates to describe interval notation. It's increasing from negative infinity up to 0, and it's decreasing from 0 to positive infinity. It's never constant. And the graph, that this function is an even function. Even functions have symmetry with respect to the y-axis. The left-hand side is a mirror image of the right-hand side. The axis of symmetry of this parabola is the y-axis.